All right, let's talk about the linear servo motor. We're going to see what really makes it so different.
Think about it. Most motors spin, right? Great for wheels and fans. But what about perfect, straight line motion? Usually, to get that straight line from a spin, you need extra parts, like this complicated ball screw mechanism. That adds complexity, wear, and it slows things down. So you have to ask, couldn't we do this more directly?
Well, here's the genius solution. Just imagine unrolling a regular motor and laying it out completely flat.
And this is literally what's happening. The spin just becomes a direct slide, no extra parts needed.
And that is the direct drive difference. So what does that really mean for performance?
By cutting out that ball screw, the whole system gets simpler, way more rigid, and has fewer parts to break down.
The result? You get a compact, quiet, and much faster system. And that means a huge boost in productivity.
It's not just faster, it's smarter. Newer models are way more efficient, using 25% less power. Okay, so where do you actually see this speed and precision making a difference in the real world? In alignment systems, for one. We're talking about placing microscopic parts with insane accuracy. These motors are perfect. And in automated assembly, their speed is key. They cut down the total time it takes to build something. Think about high-speed electronics, too. They let machines place tiny components onto circuit boards super fast.
But all this power and performance comes with a pretty big catch. This is not your average motor.
We need to talk about the magnetic force here. We're talking 2.5 tons of attraction.
To put that in perspective, a magnet plate the size of a sheet of paper could lift 2 cars. So yeah, safety is a huge deal. You have to be incredibly careful with tools, electronics, even watches. And here's the thing, a simpler machine doesn't mean it's a simpler system. It needs some very complex control. All that power has to be controlled by some serious software to tell the motor exactly what to do. And this is where engineers really dial things in, fine-tuning tons of parameters for maximum performance. So it all comes back to this one simple idea: direct linear motion, with absolutely nothing getting in the way. So the key takeaway is this trade-off. You're swapping out complex mechanics for complex electronics. Which makes you wonder, as our control software gets even smarter, what other machines are going to go direct drive?